Afternoon to all of you. Hi, good afternoon everyone. I hope so I'm audible properly. Am I? Please let me know in the comment box if I'm audible properly or not, so that I can start this class on time. Hi. Am I audible, right? Okay. Okay. Thank you so much for confirming. Thank you everyone. Okay, so let's begin this session as we are starting a general science portion. So as you already know that general science is basically consists of three major subjects. First is your biology, then after chemistry, and then after your physics. Okay, we can take any direction part now. So let's begin this session. As you can see, the first chapter just behind me on my slides, introduction and measurements and SI unit and practice. That means what we are going to start today, we are going to start the physics portion. Before starting this session, if you are watching this session in a recorded format, definitely you can put all your doubts in a doubt window. Either me or my teaching assistant will answer this query. So by luck, or if any issues there, if you missed your live session, in that case you will be recorded session definitely, but in that recorded session even you can put your doubts or your query. Okay, so it would be partial live for you. Now as we are starting a new subject, that is your physics part. So definitely just go through the syllabus portion, or I must say the most important chapters which we need to cover in this particular session. And whatever, if you find anything, if it is not mentioned, ma'am, this chapter is not mentioned, just ask your query right now. Okay, so basically we are going to start this session or the physics part with around 12 chapters. Okay, the first session, as you can see here, that is a unit and measurement. Each and every type of units, what are the fundamental units, what are the derived unit, how the systems work. So this will be complete or covered from the unit and the measurement part. Second is motion, force, gravitation, work power, energy, fluid mechanism, little bit, refraction of human eye, sound, or okay, and one and more chapters. For example, heat and thermodynamics, okay, sound waves energy. This will be covered as your complete syllabus. Electricity, magnetism will also be covered. Okay, so this will be examples of your syllabus which we are going to be covered in your physics chapter especially. Okay, clear everyone? Now let's start this session. As the name suggests, is regarding is regarding the measurement and SI unit, in which also involve your practice session. So starting from here, for example, let's take an example of physical quantity. So let's consider it first of all. So basically anything, for example, if I ask you what is your height, for example, if I ask you or your mother asks you, just take a 1 liter of milk, just take a half liter of milk, or just take a milk. Even if she is asking for you, just bring a milk from a market, even in that case, you need a quantity, right? You need a physical quantity. So physical quantity, basically it is a term which can be measured by anything or any output. We can use it as a quantity. For example, if I ask you what is your body temperature, and you'll answer me quickly, it's 9.82 degrees Celsius or it's 37 Fahrenheit, right? That means it can be measured, right? You can measure something. You can tell it in a numbers or in a unit format. So whatever which can be measured is termed as quantity or a physical quantity. So the physical quantity, as you can see the definition here, the quantity which can be defined and measured are called physical quantity. If I ask you your body temperature, if I ask you your height, if I ask you bring a milk, bring a something liquid from the market, definitely you can define me in a terms of measurement. It will be termed as physical quantity. For example, force, for example, distance, for example, time. Clear? Everyone, this definition is clear? There's a resounding. Any glitch? Everyone, this definition. Wait. Now, please confirm. Now, I think it is clear. Clear? Rakesh, please put your comments. Clear? Thanks. Okay. So whatever we can be measure or defined as a measurement part, it is termed as your quantity or the physical quantity. If I ask you your height, you will answer me with 5.52, with 5.4, something like that. If I ask you your body temperature, you will answer me 98.5 or 98.7 degrees Celsius. That means you can measure these things, or whatever can be measured is termed as physical quantity. Clear the definition? Now, the measurement of physical quantity, basically what is the measurement? So it is a process of comparison of an unknown quantity with the standard quantity, but hold it because you don't know the standard quantity for now. Now, whatever I have mentioned that which can be measured is termed as quantity or the physical quantity. Now, if I'm asking you anything, for example, just take your height or just take your body temperature, you answered me 98.7 degrees Celsius, right? What you have mentioned, the number, the digit, as well as there was a unit. Now, what is unit? See, unit in which the quantity is being measured, okay, is termed as unit. So that is why to define any quantity, there's a two parts play important role. First is unit. Unit is basically the quantity which the quantity is being measured is termed as unit. And what is magnitude? Which express how many times the above selected unit is contained in the given quantity. For example, in a force of 15 Newton, 15 Newton force is the physical quantity because we can measure the force. 15 is the magnitude. The number is representing a magnitude and N stands for a unit. Clear, everyone? So, what I have told you that whatever can be measured is termed as physical quantity. If you are measuring something, there would be two things very important and play a very important role. That is a number. In a physics language, we will call it as a magnitude. Okay. And the second thing is your unit part or the unit by which you are actually expressing your being measured. Clear, everyone? This part. Now, moving to the next. Now, see. So, I have mentioned that physical quantity, right? Now, the physical quantity, whatever the physical quantity it is, be classified. Now, see the classification piece. The physical quantity can be classified on the two major parts. First is on the basis of unit and on the basis of direction and magnitude. I have already confirmed you what is the magnitude, the number, okay. And the second is on the basis of measurement or unit. On the basis of measurement / unit, okay. This will be a classification of your physical quantity. Now, on the basis of direction and magnitude, so whatever can be expressed as a physical quantity, you can express it whether in a terms of just a magnitude or in a terms of direction as well, okay. So on the direction and the magnitude, for example, if I ask you your height, you have answered me 5.2 or 5.4, whatever, okay. You are not going to answer me 5.2 in a south direction. You are not going to answer me your body temperature is 98.7 in a west direction, right? So the quantities where there's no need to mention, or the quantities doesn't require the direction part, is termed as scalar quantity. So here on the basis of direction and magnitude, it is further classified into a two part. Your first part is scalar quantity, okay, as well as vector quantity. Clear this section? Now, the scalar quantity, there is no need to represent the scalar quantity with the direction. Okay, so I am just writing it like this. No need to mention or represent with the direction. There is no need of direction. Okay, you will just answer it just by the quantity part, for example, or you can say only magnitude required. Okay, we can also say it like this. Only the magnitude are required. These quantities are termed as direction. For example, if I ask you just bring a 4 kg sugar, you will bring a 4 kg sugar or 5 kg sugar, but you are not going to bring 5 kg sugar from the south direction. Okay, clear or getting my word? Huh? Getting my words or not? Please answer me now. Okay, so for example, your area, these type of things are usually termed in a scalar quantity. Now, as the name suggests, that is your not suggests, but with the expression of these scalar quantity, you will be more able to understand the vector. What is vector quantity? So the quantity, any physical quantity which is going to be represent, okay, which is going to be represent with direction plus magnitude. Okay, any quantity which is going to be required to represent, going to be required the direction as well as the magnitude, is termed as your vector quantity. For example, just take a one piece of iron which is placed on a plane surface, and we are putting around 100 Newton force on it. Now you have to, if you want to squeeze this iron, you have to apply this force from the upward direction, right? If you just want to replace it from this direction or from to the left, actually you have to apply this 100 Newton force from your right direction. If you want to slide it into a left direction, you have to apply that same force into a west direction. And if you want to basically if you want to pick this particular iron, you will apply this force in a upward direction. That means force is your vector quantity. Why? Because you have to make sure that you are applying a force in a particular direction. You are also giving this 100 Newton, which is your magnitude, and you are also giving the direction part, which is your direction part, and that is why it is termed as the vector quantity. Clear, everyone? Scalar and the vector quantities are now clear or not? Okay. So, scalar, just a scale. This will be your trick. So, just a scale. There is no need to place a scale like this or anything. Okay, just if it is just a scale, there is no need to mention a direction. If it is a vector, we need to mention the magnitude and the direction. Clear, everyone? Okay, thank you so much. Now, moving to the next part, and your next classification is saying regarding the on the basis of measurement of unit or the power. For example, okay, take an example. You are riding your Activa. As I have Activa, so I am taking an example of my Activa. Okay, so for example, if you are also riding your Activa or any vehicle, value, exactly, value quantity, it should be in your number. Okay, wait, I am giving you an examples also here. Just a minute. Wait. Let's complete it first, then after we will switch to that part. Okay. Vector or the scalar again. See. For example, if we take an examples of scalar quantity first of all, so to represent the scalar quantity, there is only a magnitude we require. There is no need to require a direction part. For example, your length. Okay, no need to define you. For example, if I take this bottle and you are asking me, ma'am, what is the length of this bottle? I will just give you a magnitude. That is 1 meter long. Okay, I am not going to give you an answer. It is a 1 meter long in a west direction. Getting my word? So, length, your time. Okay, just that means, for example, it is a 120 right now, 120. That's all. No need to mention 120 in the south direction. Clear? Volume. Okay. Volume, that means if I ask you bring a 4 kg or 5 kg sugar, you just bring a 5 kg or 4 kg sugar. That's all. Okay. Distance. These are your scalar quantity, which can be shown only in a magnitude. No requirement of direction. Now, vector quantity. Vector quantity can be represented with magnitude. That means number, value, quantity plus direction. Take an example of that force part. Okay. For example, the physical quantity which require magnitude as well as direction is termed as the vector quantity. Example, force. Okay. For example, velocity. Oh shit. Velocity, momentum. Once we start covering the chapters of physics, you will definitely get to know what is momentum, what is velocity, what is force. Okay, so just take it as an example. There's no need to dive into a definition of velocity or force or anything. By the time you will definitely get to know what is force or velocity and other examples, right? Okay, so this is the complete part of your scalar and the vector quantity. Now we can switch. If you are okay with this segment, please put your comments yes. Okay. Answers, please. Then what is measurement, ma'am? Wait, I'm coming on that. I'm coming on that part. The measurement part. Okay. Now, let's take it on the basis of measurement. What are the quantities? So, if we take on the basis of measurement, see here. Now, on the basis of measurement, we have actually three major quantities. First is fundamental quantity. First, okay. Second is your derived quantity. This will be your derived quantity. And then after, there is a further segregation, that is a supplementary quantity. Sometime you will, it is mentioned in the book, sometime it is not. So, supplementary quantity. Okay. Now, what is the fundamental quantity? First of all, so the quantity which are completely independent. That means without being dependent on the other physical quantity, they are not going to be dependent on any other physical quantity. We can directly take it as a whole quantity. It is termed as fundamental quantity. So we can say the quantity which are completely independent. After example, you would be able to understand it clearly. Which are completely independent. Or you can say not based on other. Okay, not based on other. Basically, are called fundamental quantity. For example, if I ask you what is the length of this remote, there is anything which you need to take any other physical quantity with the help of other physical quantity, you will tell me the length of this particular item. Okay, just a minute. Let's understand first of all the derived. Now the derived quantity which are dependent on other, which are dependent on other are termed as derived quantity. What if I ask you what is the area? For example, there is a one square shaped structure. Now if I ask you what is the area of this particular shape? Now to calculate the area, you need what? You need length into width gives you a area. That means this area is dependent on the length and the width. So it is the derived quantity. Getting my word? And now come to the fundamental again. So the quantity which are independent and not depends on other quantity is termed as fundamental. Now fundamental, how many fundamental quantities we have? So we have 7 fundamental quantity. Clear everyone now? Huh? Okay. Clear? For example, you can also take another example in a derived part. For example, if I ask you who was riding your Activa and what was your speed, है ना? So to calculate the speed, you need to know your distance and your time, right? That means speed is your derived quantity. It is not a fundamental quantity. Why? Because it is based on distance and the time. While to calculate the distance and the time, you are not going to depend on any other quantity. So distance and time are the fundamental unit. Exactly. Wait, I am telling you what are these 7 fundamental units. Okay. See here. Just see this slide or the table. So as I have mentioned you that the fundamental units which are independent or which are not depend to calculate any other unit is termed as fundamental. How many fundamental unit we have? We have 7 fundamental unit. Now the 7 fundamental units are length, mass, time, electric current, temperature, luminous intensity and amount of substance. Clear? These are the just 7 fundamental unit. You can answer it by yourself even. To calculate the length, is there any physical quantity you need? No. To ask, if I ask you what is the mass, what is the basically mass of a product, that means in that case there is no need to take other physical unit. Same with time, same with electric current, temperature, luminous intensity, amount of substance. And yes, please make sure that you are learning this table by your heart. Okay, because sometimes they will ask you just a random question, which of the following is not a fundamental unit. So among this these 7 units, if you have any options, just click on that. Okay, so please make sure that you have memorized these 7 fundamental unit, as it will definitely create your question. Okay, amount of substance, definitely we will take these each and every fundamental unit will be defined here. So just wait and watch, just wait. I'm coming on that part too. Okay, everyone, clear these 7 fundamental unit. These are the 7 fundamental unit. Please take it as a SI unit also. Well, I will define you this unit part or the MKS or CGS or SI unit part. But still, for the memorization, length, SI unit is meter. Mass, SI unit is kilogram. Time, second. In any system, whether it is MKS, CGS or FPS, it will be a second for all. Electric current, ampere. Temperature, Kelvin is the standard. Please make sure a lot of students understand it as a Celsius. Okay. Luminous intensity, it is a mole. Amount of mole. Luminous intensity, candela. Okay, just by mistake. I think there was a typing mistake. Okay. Now back to that chart. Okay. So finally, we know about the fundamental. We know the direct. Now, what is the supplementary unit? Actually, in a starting or in an initial period, we understand these 7 units, these 7 fundamental units was more than sufficient to calculate anything or any quantity. But later on, as we go in a modern part, there's a 2 important conditions arise, and supplementary unit are the part of them. So supplementary unit are also called geometrical unit. Geometrical unit. For the circle and any sphere part, you can call it as a solid angle named as a radian and stay radian. So we have 2 supplementary unit. What is supplements? I think in a graduation or in your CBSE exams, there was a supplement of number 1, supplement of 2. That means we are adding to clear it, right? So we have 2 supplement units. These angle, plane angle we can say, and the solid angle. Now plane angle is radian, the SI unit is radian, and solid angle, the SI unit is steradian, RAD, SR. Clear? Okay, so just keep in mind. Okay. Kelvin symbol ke, Kelvin symbol ke, what happened? Arey baba, shit. Just a minute guys, I'm taking it clear. Second, typing issues. Okay. 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 Thank you so much. Okay. Clear? The supplement units are clear now? See here. So this is a complete chart we can take for the physical quantity. Okay, what we have studied. So to represent, so which can be measured is termed as physical quantity. Now physical quantity can be measured in a two aspect. First, to represent the physical quantity with only the magnitude is termed as a scalar quantity. To represent any physical quantity with the help of magnitude as well as direction is termed as vector. Now on the basis of measurement or unit, we have a three segregation. Fundamental unit, which are completely independent unit. There is no need to require any other unit to calculate the fundamental units. And the number of fundamental units we have 7. Derived unit, which are calculated with the help of other physical unit, especially the fundamental unit. With the help of fundamental unit, we calculate the derived unit is termed as derived. And we have 2 supplementary unit. Is that clear now? Okay, moving to the next part. Now, measured quantity, its magnitude especially, comprises of number and unit, which I have already mentioned. Okay, to express, to measured any quantity, its magnitude especially comprises of what? Comprises of unit as well as the number. For example, if I am asking you force 100 and Newton, right? 100 is your magnitude, Newton is your unit. Clear? For example, 4 kg or 5 kg. 4 is the magnitude, 5 is the magnitude, kg is your unit. Now, to calculate or to define this unit segment, we have our systems of unit. Okay? So, the following systems of unit are common in use. For example, this is your CGS. See, what we need to calculate? We need to calculate the length, mass and time. If we are calculating this length, mass and time as per the CGS, it would be calculated as length centimeter, mass gram, T will be same for all, second. Okay. If it is FPS, in that case, length will be measured in a foot, mass will be measured in a case of pounds, and time will be measured in a case of second. Okay, second. MKS, again length, mass, second. If we are measuring something in a MKS system, length will be measured in a meter, mass will be measured in a kg or kilogram, or second will be time. Okay. Now, so I guess there are 3 systems we use to measure the quantities, right? For example, you have 5,000 rupees, okay, and with the 5,000 rupee, you just travel America, and you just give your 500 rupees to a customer or someone. Now he will say, this note is not here, this is not a currency. That means we are taking it as a country wise. So if some countries follow the CGS, some countries follow the MKS, some countries follow the FPS. So that to clear the confusion, the international system or the system international gave the SI unit, which will be considered as universal. Okay. So this system is an extended version of MKS. So basically, the SI system is completely because they were the friends, so they just said, yeah, please measure the length into a meter, please measure the mass into a kilogram. So that is why the whole SI system is actually associated with the MKS or the MKS system. The system defines 7 fundamental quantity, as I have already mentioned you here and there. Okay. Okay, so basically in so whatever we took in a SI system, that is termed as a universal, it is termed in a French system international, which is based on MKS, and the major your 7 fundamental unit are defined as a MKS system. Clear? Okay. See, for example, your length measuring meter, which is MKS. Okay, mass kilogram, MKS, time second. So each and every, basically the fundamental units are based on a MKS system, which is a SI system. Clear? Okay, now. Good afternoon. Dinesh, no. Okay, just a minute, guys. Now, so basically there are some standard prefix we actually use. Sometime they can raise a question from here. Sometime when the numerical value of a quantity become very large or very small, prefix are used. This question has been arised. Okay, so when we use prefix, options were in a statement format, so the question has been arised, are used together with the unit to make the numerical value of quantity more meaningable, right, or the manageable. So for example, starting from here, the small measurement. So small measurement, if it is 10 to the power minus 1, you can write it as a decimeter or DA. 10 to the power 2 centimeter C, and go on. 10 to the power minus 24 Yoto. Zepto you have heard, it is actually a physical quantity termed as when 10 to the power minus 21, which actually means it. Then after your suffix in a large measurement, 10 to the power 24 termed as iota, Y. 10 to the power 21, it is a zeta and Z. Okay, so just go through the table for the safe side of the question format. Okay. See. Now, let's have a definition of those 7 fundamental units, especially someone was asking also. So that is why just take it as a definition. What is meter? Now, the 1 meter is the distance. What is it? Distance traveled by light standard 1 by 299,792,458 of a second in a vacuum. So this is a definition of 1 meter. If you are preparing for, especially for the railway exam, go through the definition. If you are not, just you can ignore it. Kilogram. 1 kilogram is the mass of a cylindrical piece of a platinum iridium. This question has been asked. In a case of, in a definition of kilogram, what is the alloy is used? So actually it is a iridium alloy maintained at 0 degree centigrade, kept at International Bureau of Weight and Measure at near Paris. It is a definition of kilogram. Second, 1 second is the time taken by a cesium atom. Okay, there is an atom cesium to complete number of these vibration is termed as second. Light year, very important definition, whether you are preparing for SSC or railway, both important. Light year is the distance traveled by a light in a vacuum. Please mind this word, vacuum, in a 1 year is termed as light year, is equals to 9.46 into 10 to the power 15 meter. Once your physics done, in that after that you can forget this unit, otherwise you can't, because it will be repeat more and more. 10.46 into 10 to the power 12, but the unit change, as you can see, it is kilometer. Astronomical unit, very important. One more thing, there was a question. Light year is a unit of, so sometime a lot of students ask it like a length or blah blah. So light year is a unit, is the distance. Clear? Now, astronomical unit equal to the mean distance between the earth and the sun, and the unit is AU is equals to 1.496 into 10 to the power 11 meter. This is a parsec. It is the largest unit of distance. Now, this will create your static questions. What is the largest unit, smallest unit, like this, okay? So, largest unit of distance is parsec, is equals to 3.26 light year or 3.08 into 10 to the power 16 meter. If you are okay with the physics, just calculate. If you are not, please go through and revise your chapter again and again. Fathom. Many times they have asked this question from the fathom. The depth of a ocean. I think you have heard about the tool that is a fathometer, right? So, fathometer or fathom is a unit. Measured in fathoms, 1 fathom is equals to 6 feet, okay? Is equals to 1.828 meter. Nautical miles, you will learn this nautical miles even in economics GDP part, right? Is used to measure distance in the seas and the ocean. 1 nautical mile is equals to 1852 meter. Very, very important. They have raised this question. Okay. Even in our Indian Ocean part, 12 nautical mile is considered as Indian boundary. 12 nautical mile. Okay. So, 1 nautical mile is equals to 1852. Please mark the unit. These are the unit of length. As you can see, AU. Sometimes they will raise a question. 1 parsec is a unit of. This type of question arise from this segment. So, AU, light year, parsec, mile, nautical mile. For me, angstrom, millimeter. Angstrom is very confusing. Light year is very confusing. And parsec is very confusing. Okay. And please make sure that these are the unit of length. This list is important as per exam point of view. Unit of mass. Which of the following? Quintal or AMU is the very confusing part. AMU is considered as the unit of mass. This is a unit. Metric ton, solar mass is also confusing. So, keep in mind the solar mass. Otherwise, the name represent metric ton is the mass. Milligram, gram, kilogram, quintal. Unit of time, 1 minute, 1 hour, 1 day, 1 month, 1 year, 1 decade, 1 century, 1 millennium is the unit of time. Unit of some physical quantities, for example, area, meter square. So, there is no need to revise this segment. As we go on physics part, physics syllabus, there will be a separate chapter of each and every quantity almost. Okay, so if you want to skip this some physical quantities part, you can skip it. Later on, we will consider the density, what is relative density, what is the speed, how to calculate it, what is acceleration, what is momentum. So, right now, if you are not understand to what is momentum, what is force, you can skip this table. You can only skip this table. Okay, do not skip the whole PDF. Okay. Now, here's your first question. Please answer. As this session contains practice, so here I am with some questions. Now, answers please. Number of basic SI unit is answers please. 7. Very nice, very nice. And please, one more request. is please be consistent in your classes. Okay, once you skip a one class, the thread will just break. Okay, so do not break this thread and please be consistent. Okay, 7. Okay. So international system of unit already has 7 units. Correct answer is option number. Okay. The units, I guess you know: second, meter, kilogram, ampere, Kelvin, mole, and candela. Okay. Next. Which of the following is not a fundamental unit? Which of the following is not a fundamental unit? Very nice. Beautiful answers. Okay. The correct answer of this question is liter is the right answer. Liter is not a fundamental unit as meter, kilogram, second. Okay. This is a type of question. Okay. Next question. Light year is a unit of. Light year is a unit of. Distance. Very nice. Correct answer option number B. You can download this PDF just after the class wrap up 1 to 2 hour. Okay, so you can download this whole PDF with the questions. Next. Which of the following is not the unit of time? Which of the following is not the unit of time? Okay. Anyone else? Option 1, A. Sure. Parallactic second is not a unit of time. Right, because it is a unit of distance. है ना? It is a unit of distance. So obviously it is not a unit of time. Correct answer A. Next question. Your next question is here. 1 Fermi meter is equal to. B just 15. ठीक है. Okay. Fermi meter, basically it is a unit of spatial measurement of length, right? Which is equal to 10 to the power minus 15 meter is the correct answer, and it is denoted by FM. It is denoted by FM. Clear? Okay. So the correct answer, that means 1 FM is equals to 10 to the power minus 15 meter. Next question. You will get this list from that Zepto or Yeta wala part. Next. SI unit of luminous intensity. Quickly. So there's your homework for tomorrow, that please revise your 7 fundamental unit. Okay. I will ask a random question from a random person. Candela? Candela. Next question. Parsec is the unit measurement of. parsec. It is denoted as PC. B, ठीक है, astronomical distance. Distance was okay. Sometimes it is termed as parsec, sometimes it is termed as parallactic second, which is again a unit of distance, है ना? And density of star, no. Astronomical distance, correct answer, option number B. Brightness of heavy body, no. Next question. 1 light year is approximately equal to. One light year is approximately equals to. That's to the power 15 meter. Okay. 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 So it should be 9.46 into 10 to the power 15 meter. है ना? Correct answer is meter. If it is kilometer, it should be 12. 10 to the power 12 kilometer. In that case, it would be right for us. If it is in centimeter, if it is centimeter, 9.46 into 10 to the power 17. 17. Suppose they have a question like which of the following is the right for 1 light year. Options were 10 to the power 12 kilometer, 10 to the power 15 meter, 10 to the power 17 centimeter. All of the above. In that case, you need to know values with the other units. Okay. Next question. Okay. No next question. As I have a next class. Guys, this PDF contains lot of questions. Wait, I'll show you. Around okay, so 71 starting from this. So I guess around 50 question I have added of the chapter measurement and measures, unit and dimension and measurement. So please go through the PDF. Please download the PDF and try to answer this question and revise your content. Okay. See, no ma'am. Oh, see. 10 to the power 16 meter. No. 15 meter would be a right answer. Okay. So please go through the PDF for your revision part and we'll meet you in your next class. So thank you so much. On the screen of your right hand, there's a symbol like this. So it is a feedback symbol and you can give your feedback here. Okay, just after the class or during the class even. So please give your feedback. We'll meet you in the next class, everyone. Please keep revising your content. Bye-bye. Take care and thank you. Okay, so actually, I think a lot of students was asking me that ma'am, this polity is finished or not. So not, because this was a demo class of our newly launched course, everyone, and you can also a part of this course basically, which is going to be start from today. So you have not missed a single class, right? You can find this course on our official website, that is your oliveboard, and in an English segment, you can check this course. SSC CGL Foundation course. So this is a class of your SSC CGL Foundation, complete foundation course, which is comprises of concept plus questions plus your practice question and your basically doubt clearing session also involved. Okay, so please go through the application and check out this course on our official application by clicking subscribe. Okay, classes has been started from today. Don't forget to join this session live. Bye bye. Thank you.